Okay, so more examples now using the chain rule, okay? But we're going to do it the short form, yeah? So we're not having to write u's in and so on, all right? Now we've got our function here, and we're going to differentiate it. So remember, I call it y equals, and then straight away then I can find what dy dx is, all right? So dy by dx. Now, what you do, of course, is think of this, as I said, as a function of a function, right? That's what you've got to do. It's a function acting on another function. Right? So the inside function is 5 plus 7x squared, and there's a function acting on this. Okay? In other words, whatever you've got in here, you do something else to it then. You put it to the power 10, right? So that's another function. Okay? Function to the power 10 will do something to the inside function, which is 5 plus 7x squared. So that's why I say function of a function, right? Function inside, and then there's the bracket, the power 10 is acting on that function. So what you do is, with the chain rule, you differentiate the outside function first, right? Always the outside one. The outside one is the one with the bracket to the power 10. That's on the outside, isn't it? So you differentiate bracket to the power 10. So bring the 10 down, okay? And then you break the bracket out again, and you reduce that power then by 1, so you get power 9 now, right? But then don't forget then, with the chain rule, you've got to times it then by the derivative of the inside function. And the derivative in there, well, that's 0, and that becomes 14x. Okay? And bring the 2 down. And then you've got to simplify it, so then you get 10 times 14 is 140x. Okay? To the power 9. Well, I don't know why I've written x there. Okay, mistake that, so we don't need that there. Okay, second question, right? We've got now this, now root. Now, again, we've got to call it y equals, yeah? But the first step I would do now is get rid of that root and write it as a power. Of course, we know the square root is the power half, right? So, do that first, and then you've got no problem. So dy dx then, as I said, differentiate the outside function, the bracket to the power half, bring the half down. Now, when you bring the half down, you've got to reduce that by 1, so half take away 1 is minus a half, and then times it by then the derivative in here, which is 24x cubed, okay? And then to simplify, right, what we do then is we write that as, well, half times 24 is 12, isn't it? Yeah? Half times 24 is 12. 12x cubed, put the x cubed to the front as well, and you get that. And what I would do as well is I'd write that then as 12x cubed. And because that's a minus a half, I take it down and put it plus half. And of course, with a plus half, it's just the square root, isn't it? Okay? So much nicer answer, simplified as best as you can. So this one now, right, this next one, again, you know, y equals, but we need to rewrite this, and in order to establish the derivative, we need to take that up, don't we? Okay, now, later on, we're going to look at products and quotients, yeah? Products and quotients, and of course, you might think of this as a quotient, okay, and you can, if you want to, think of it as a quotient, but there's no need to, because on the top, this is just a constant, isn't it? Okay, so this is the constant at the top, then you can take what's on the bottom up, alright? Later on, we look at questions where you've got x's on the top and the bottom, and we'd have to think of that as the quotient then, right? And use the quotient rule with two functions, one on the top, one on the bottom. When you've got this, a constant, you can just take what's on the bottom up and minus power, and you can just differentiate it as a function of a function. So, in this case, the outside function is this bracket, the minus 2. Don't worry about the 4. Minus 2, bring it down, and times it by that 4, so you get minus 8. Take away 1 then to that bracket, so you get minus 3, and then times it by then the derivative in there, which is 3. Okay, so you get, now bring the 3 to the front, so that'll be minus 24, okay, to minus 3. And then, as I said before, I would then rewrite this to make it nicer, minus in the front, 24, and then take that down then, because it's negative power, so you can put it as positive power underneath. Okay, so let's just do one more here. You could get something like that, right? Y equals again, right? So then dy dx, we'll bring the 9 down, differentiate the outside function first. That becomes an 8 then, doesn't it? And then you need to times it by then the derivative in here. Now, when you differentiate this, there's two terms. Differentiate always, yeah, in this case. Now, differentiate that, you get 2. And if you differentiate that, you get something as well. You get minus 10x, don't you? Now what I would do is so important, because you want to times this, don't you? What you've done here, you want to times it by the derivative in here. You've got to times all of it, so we need to put this in the bracket. That's really important. Okay? And we've got our answer pretty much done. Okay? You could put that at the front maybe, so it looks a bit nicer. And you could also, if you notice here, it's got a common factor of 2, so you could take 2 out if you wanted to. So you could write this as 9 times 2 times, well, what we're going there, that'll be 1 minus 5x there, if you take out a factor of 2. Okay, and then just tidy that up a bit. You'll have 10, 1 minus 5x, and in that bracket, 2x minus 5x squared to the power 8.